So, in last lecture we talk about discrete time signal. Today now we talk about discrete time system. Now, as you know that what is a system? Whether it is discrete system, analog system or whatever. System is nothing but a process or a device, the system where I can apply a input and I can get an output. So, that is a system. So, it may be a discrete system, it may be a education system, it may be a corporate office system. So, system is nothing but a procedure or an algorithm or set of rule, or I can say a device, where if I apply a input, I can get an output based on the algorithm, based on the procedure, based on the rule. Now, what is a discrete time system? Here I can say discrete time system. So, I said the signal is discrete time. Now, I talk about the system is also discrete time. So, what is a discrete time system? So, discrete time system is a device or an algorithm that operate on a discrete time signal. So, if the input signal is discrete time and the algorithm that will operate on that signal will be called discrete time system. So, I can say that you know that yn is nothing but a h of x of n, where h denote the system. Or I can say, let us say yn output is the combination, this combination of the input and previous output. So, that is also a system. I can easily determine the transfer function of the system. What will be the h in this case? So, what is the h? Well, the transfer function of a system. It is nothing but the output by input. Now, if I say that, very simple, you know the Z transform. So, what is the meaning? That I can say is, if I converted to the Z domain, I said yz is nothing but a 0.8 into yz into z to the power minus 1. Z to the power minus 1 denote one sample delayed, n minus 1, one sample delayed, plus 0.5 x of z plus 0.9 x of z into z to the power minus 1. I can easily calculate the value of yz by xz, which is nothing but a hz, transfer function of the system. So, discrete time system, input is discrete time signal, it may be a device, algorithm, procedure, whatever, and I will get an output which is also an discrete time signal. Now, suppose adder, the purpose of the system is that where the two signals will come together, they will added up and that give me the output. So, I can say it is represented x1n, x2n plus them. So, this system is nothing called a adder. There may be a 3 input, 4 input, does not matter, x1n plus x2n plus x3n plus x4n plus x5n, does not matter. Constant multiplier, or I can say discrete amplifier, I can say. So, a system which multiply the each input sample with a constant number a. So, if I say this is a system, then I can say this system is called constant multiplier. Signal multiplier, two signal will be multiplied together. So, if the block diagram is look like this, there may be a 3 signal can also multiply. So, I can put another x3 here, then I can say y of n is equal to nothing but x of 1n plus into x2n plus into x3n, does not matter. So, that is called multiplier. So, when I write the block diagram of a system, this circle and cross is used for multiplier, circle and plus is used for adder. It may be a subtractor also, circle minus 1, minus, that means x1 of n minus x2 up n. Unit delay, that is I said that the signal is delayed by one sample. So, here you can say it is delayed by one sample. So, if it is delayed, it is represented at a z to the power minus 1, that means one sample delayed. Now, if I say y of n is equal to n k number of delay, x of n minus k. So, k sample delay. So, I can say it is nothing but a signal, then I can say z to the power minus k and yn. So, this is the xn and this will be the yn, and then I can say output is x of n minus k. Similarly, unit advance, I can say advance by one sample. So, when I say advance, it will be z to the power plus 1. Similarly, if I say k sample advance, same thing, it will be xn applied on a system which is nothing but a z to the power k, I get x of n plus k. Please put that arrow marking when you write the circuit block diagram or signal block diagram, because arrow is the flowing of the direction of the signal, that is must, that is mandatory. Okay? Then let us say I told you to draw the block diagram. So, elementary system block diagram you know. Let us say I told you draw the block diagram of the given system. So, this is my system, yn is equal to combination of this one. So, if I say how many delay function are there? 1, 2, 3. So, let us say suppose you do not know anything, do not remember when you write the, when you draw the block diagram, do not remember anything, see the first signal. Let us I say this side is x of n. Okay. So, signal is flowing this direction x of n. So, I require x of n, one part has to be delayed by one sample z to the power minus 1. So, here I get x of n minus 1. Then I know I have to, I have to generate up to this. So, this is nothing but a, there is a adder where x of n will be multiplied by 6, write the vector there, will be added up with x of n minus 1, where the multiplying factor is 0.4. So, I get this one is nothing but a 0.4 x of n minus 1 plus 6 x of n, this point I get. Now, what I want output is y of n. I want y of n, one 2 sample delay signal. So, let us say this is y of n, if I trap the signal here, then I get z to the power minus 1, then I get z to the power minus 1. So, I can say this is nothing but a y n minus 2, one sample delayed, another one sample delayed. So, the 2 sample delayed, so y n minus 2, and this has to be multiplied by 2, and I required y n minus 1 also, this is y n minus 1, and this has to be multiplied by 3, then both has to be added up here. So, that is the block diagram of the system. So, any system people will give you, you can write down the block diagram of the system. So, this is called discrete system block diagram. Next we come that how to minimize this delay, structure 1 implementation, structure 2 implementation, I will come later on. So, any system is given to you, you can draw the block diagram of the system without remembering anything. If you know the logic, you can do it by a minute. Okay? Next one, static and properties of the system. Similarly, signal property, periodic, aperiodic, time invariant, time variant. Similarly, system also has a property. What is the property? Static and dynamic system. Sometimes it is called memoryless, or with memory system. A discrete time system is called static or memoryless. So, static system means memoryless. The output at any instant A depend at most on the input sample at the same time. That means, if I require to remember, let us say y of n is equal to 2 into x of n, I do not have to remember the previous sample. Present output depends on the present input. Now, suppose I have an y of n is equal to 2 into x of n minus 1 plus 3 into x of n. So, I know I have to remember the previous sample. So, when I say z to the power minus 1, that means I have to store the previous sample value to get the current sample value. That is why that is called with memory system. So, memoryless means I do not have to store the previous or future value. With memory means when I have to require to store the sample. So, suppose I said y of n is equal to x of n plus 1, that also require memory. So, either a system will be with memory or without memory. If it is without memory or memoryless, then it is called static system. If it is with memory, then it is called dynamic system. Clear? Then time invariant and time variant system. Time invariant and time variant signal I have said. What is said? If the properties of the signal does not change over the time range. So, if I say a system does not change its property over the time range, that means in mathematics I can say I have a signal x of n, if I apply and I get yn, then if I apply x of n minus k, I should get yn minus k, because properties of the system does not change. If it is x square n minus k, then it is not. If it is not yn minus k, then I cannot say it is a time invariant system, like the speech signal, the properties, vocal cords. When I say something along the timeline, the shape of the vocal cord is changing. That means characteristics, this denoted by h, is changing along the timeline. So, I cannot say this is a static system, this is a time invariant system, this is a time variant system. Along the timeline, property h is changing, that is why it is time variant system. Understand? Let us example. Let us say y of n is equal to x of n minus x of n minus 1. Prove that the system is time invariant or time variant. Let us say I told that whether the signal system denoted by this equation is a time invariant or time variant. So, how do I do that? Very simple. Let us say I apply a k sample delayed input. So, I apply x of n minus k. Instead of x n, I apply x of n minus k. So, I can say y at that point. So, y at delay, when I apply the input k sample delayed input. So, it will be x of n minus k, k sample delayed, minus x of n minus k minus 1. Now, if I collected the k sample delayed output, that means if I say y of n minus k, so I collected the 10 k sample delayed output, so that will be x of n minus k minus x of n minus k minus 1. See that y n k, that means the output due to the delay in input signal, and the output same delayed output. is same. So, I can say y n k is equal to, since y n minus k, then I can say the system is time invariant, because the properties of the system does not change with time. Clear? So, I can give any system, you can test whether it is a time invariant or time variant. Similarly, linear and nonlinear system. When I say a system is linear, when? This test is given, this is very important properties of a system. Linear system, nonlinear system. How do I test it? I am not reading the slides. So, think on it in your mind without seeing the slide. Just think on it. Close your eyes and think. How do I say a system is linear? That means it should support superposition principle. What is superposition principle? That means if I apply individual input and collected output, and if I apply combined input and collected output, so both will be same. That means if I say I have a two signal x1n and x2n, and their multiplying factor is a1 and a2. So, if I add the input and apply to the system, the output I get must be equal when I individually signal I apply and output I add. Have you understand? So, I apply x1, take output y1, I apply x2, take output to y2. Now, I apply x1 plus x2, I get an output y3. So, y3 must be equal to y1 plus y2. So, whether I individually apply the signal and combine the output, or I combine input and collected the output, both will be same if the system is linear. Okay? So, let us example, yn is equal to n of xn, n is a number, where is from 0, 1, 2, 3 or minus 1, minus 2, let us say for all n. I have to test whether this is a linear system or non-linear system. So, let us say I apply a signal which is x1n, which is equal to, let us say apply a signal x1n and another signal is x2n. So, when I apply a x1n, let us say output is y1n. So, y1n is equal to, let us say I multiply a constant also, a1 x1n and a2 x2n. a1, a2 are the multiplying factor. So, I can say y1n is equal to nothing but a1n x1n. y2n is nothing but a2n into x2n, because I applied a2 x2n. So, I get n into xn is the output. Now, if I apply a1 x1n plus a2 x2n as an combined input, which is let us say x3n, then what is the y3? I said y3n is equal to, I applied combined n. So, n into a1 x1n plus a2 x2n, which is nothing but n into a1 x1n plus a2 x2n, n into n will be multiplying both. Now, I said, now you can see that y3n is nothing but equal to y1n plus y2n. So, I can say the system support the superposition principle. That is why I said this system is linear system. Let us say take this system, same input is applied. So, what is y1n here? In this case, it is nothing but a1 square x1n. What is y2n? Is nothing but a2 square x2n, or x1n square x2n square. Now, if I apply this combined input x3n, then I get y3n is equal to nothing but a1 x1n plus a2 x2n whole square. So, I get a1 square x1n square plus a2 square x2n square plus 2, because a plus b are whole square, 2a1 x1n into a2 x2n. So, I can definitely see that y3 is not equal to y3n is not equal to y1n plus y2n. So, that is why I can say this system is not an linear system. So, what is the criteria for linearity? What about the system? It should support superposition principle. That is the criteria. Okay? Next, causal and non-causal system. A system is said to be causal if the output of the system at any time n depends only on present and past input. That means, if y of n somehow depends on either y of n plus 1 or x of n plus 1, then I can say the system is not non-causal, because futuristic input is also required. So, it is not causal. But if it is only depends on present input and past input or past output, then I can say system is causal. Then stable and unstable system. So, you know that if I apply a bounded input, I should get a bounded output, then only I can say the system is stable. If I apply a bounded input and I get an infinite output, then I said system is unstable. So, for a bounded input, it should give me the bounded output, then only I can say system is stable. Okay? So, those are the, you can say, the properties of the system. So, I can give you that many equation of the system, and I can ask you test whether it is causal, non-causal, whether it is linear, non-linear, whether it is whether it is a time variant or time invariant system. So, those things you can do. Okay? Thank you.